Welcome to our next tutorial of Mesh Surface for SOLIDWORKS. As you can see on the screen, we have already a part that has been modeled, and I will bring the scanned object using the import mesh command from our menu. In this case, I don't really care about how this is in space, so you can use this option on or not, but make sure you set the right unit. And let's see how the object looks like. This is the part of the physical object that has been manufactured, but if we take a look, it's positioned somewhere arbitrary in space. But furthermore, what we can see, there is a hole. What I mean is that probably this part has been manufactured based on the drawings of the CAD model, but then some modifications have been applied. Let me just show you here. As you can see, there is another hole. So the goal here is to start working on the existing model and improve it so we can match the physical object. In order to do this, we actually need to place our scan data in regards to the already existing CAD model. And I'm going to show you how to do this. In Mesh to Surface, we have a function which is called Align Mesh to CAD, which you can find on the main toolbar. Once we get to this mode, you can see that the mesh has a manipulator on, and using your arrows and the planes, you can actually move and try to adjust this object next to the CAD model. You can do this manually by rotating the object on the screen and in space and place it next to the CAD model. But we provide some more efficient features to do this. The first one is what is called move to the model. How it works, it will just take the center of gravity of the scan data and take the center of gravity of the visible CAD bodies and will translate the object so they match. By pressing this, you can see that it just placed the scan data really close to the CAD model. Then you can carry on, and using the manipulator tools, you can probably adjust this model in a more accurate way. Of course, you can do this by eye. So there is another button here which is called as a viewport. I'm going to explain what this means. I will just place the object from the front view, and we'll move this a little bit apart because it doesn't stay on my way. So I just note how my CAD model looks like from the front view. This means that the Z direction is pointing toward me. Then I will just, using the rotation button, I will just adjust the view in a similar way so I can see roughly the actual scan data the same way as it looks from the Z direction from the front. When I adjust this, I can just place as a viewport. As you can see, the object has been aligned roughly into the same orientation. Again, you can carry on and move and adjust your position of your scan data in regards to the CAD model. Of course, because you do this manually, you can never get this in an accurate way, so I'm going to teach you now how you can do this in the most efficient and most accurate way. In order to do this, I just take the object and place it just on the side of my CAD model, like on the screen you see now. Now we will move to the next option, which is called Endpoints Align. How this works is that you pick the same number of points, and they need to match, to be correspondent, both on the scan data and on the CAD model. So let's try to do this. Normally you just pick something that is quite obviously a corner or somewhere near the cylinder. You don't need to be accurate. As you can see, if I pick a point from the CAD model, it just turns to be blue, and the points from our mesh that we want to transform, it's colored in red. So when I'm happy with this, I need to take exactly the same number of matching points. I can just press preview. You can always use the undo command if you clicked on the wrong place. And again, you don't need to be really precise. You just roughly to create this transformation. When you're ready, you can press the preview button. If you're not happy with the results, you can press reset and carry on. Now, there is one thing that I want to say here is that when you pick these points, just try to make sure they're not aligned in a single line, but just they're sparse in space, so you can allow the software to make the much better transformation. For example, here I can just pick a point from the back, so they are sparse in space. When I'm happy, I just press preview. You can carry on, get back, and using the interactive mode, you can probably adjust and tweak these and get it aligned accurately. When you're ready, you can always just compare and see your results. In this case, I'm working with the 0.1 millimeter accuracy, and this is not too bad for the first iteration. But I will go back and carry on with the third option that we have in the Align Mesh to CAD functionality, which is called Fine Align. The fine alignment will take all the points of the reference mesh and will try to match them to the underlying CAD model. There is something which is called the surge tolerance, and the way it works is just filters the points that are closer to the given value to the CAD model. For example, in this case, the points that on the scan data that don't exist on the model will not be used because they will be away more than 1 millimeter from the CAD model. So when you're happy with this, you just press apply and you wait for the result. The software uses all the points here and optimizes the position them to match the model. When you're happy, you press OK, and you can always just go and compare your results. I would say that we got a bit closer, but I want to say another way to improve your alignment and by using prioritization of the surfaces. Because this is a physical part, in reality it's really hard to make sure that all the surfaces are precisely manufactured. So in this case, what we will need to do is probably that we have some of the surfaces that we trust most than the others. In order to use this flexibility in mesh to surface for SOLIDWORKS, what we can do is just hide this original CAD model, and then I will go to the mesh selection option. What I'll do here is I will just mark with our tools the areas of the surfaces that I trust most. For example, I'm sure that I want this plane to be used. I can use the different selection tools, and I can pick area here just to get more flat surface, and I can click on this cylinder, for example, or maybe I can pick this area as quite important. When I'm happy with this, I can just press OK. We'll show my CAD model because I need this as a reference for my fine alignment. When I go to Align Mesh to CAD, I can go to Fine Align. Now when I press Apply, the software will not use all the points from the mesh, but will use only the selected ones. And when you use these selected ones, you will get much better alignment to the model, but only based on our surfaces that we select. As you can see now, this area is green and it's aligned much better because we compromised with the top surface which wasn't used, and we assume that this has not been manufactured enough. So now, as we have, I will just unselect everything, as we have aligned our object properly in space, we are ready to go, and probably I can just use the right plane and we'll create a cross section very quickly, dragging so you can see the functionality here. I can just take a section of these and we'll create a cross section, and with this cross section later I can extract my sketch for the extrusion here as a cut, and we'll modify my existing object. You will watch the other tutorials how you can use the cross section tools and how you can efficiently create sketches directly in SOLIDWORKS. I hope this video was useful. Thank you for watching.